All right, y'all, good morning. First, we're going to go over the diagnostic quiz, make corrections to that. So make sure you have your quiz next to you. And we'll start with this number one. I know it's cut off a little here, but number one is, what is the definition of an inverse? Definition of an inverse is just switching the x and y values. Okay, that's fundamentally what the definition is. If you also wrote something like graphically reflects across the line, y equals x, that is also correct. So either one of those or any version of those is correct. Okay? Now we're going to apply that definition in the next one. It says, given the table below, create a table of values for the inverse. Again, inverse means switch x and y. So here I just need to generate a new table where my x and y values are switched. Okay? So I'm going to label this table f to the negative 1 of x. Remember, this notation just means inverse. I-N-V-R-S-E. Yep. This notation just means inverse. So here are my x values. I've got one. Okay, got my 4 tables. So these are my x values in the original. They become my y values in the inverse. And these are my y values in the original. They become my x values in the inverse. So generating the table here was just applying this definition of switching our x and y values. Okay. Number 3 gives us graphically, gives us this graph below, and it says, which of the following graphs represents f to the negative 1 of x? Again, remember this notation, if that's confusing to you, you can cross it out and just write inverse, if that makes more sense to you. Okay. So graphically, how we find an inverse is we reflect across the line y equals x. The line y equals x is this diagonal line here. So that's our line y equals x, and we're trying to flip across that line. Okay? So your answer here, if we flip across the line y equals x, your answer here is going to be this one. Okay? Because we're flipping across that line. We're going this way. So this one is your answer. Be really careful on ones, especially ones like this, if it gives you your original function. So say that this is f of x, and it tells you that this is your inverse. This is wrong because it doesn't reflect across the line y equals x. So be really careful about ones like those. All right, next 3 questions are all solving algebraically, so switching our x and y values and solving for y. I know that this cut off here, but it says find the inverse of the function below. So if I'm finding the inverse, inverse means switch x and y. So the first thing that I'm going to do to make my life a little bit easier, f of x is the same thing as y. So I'm going to rewrite this as y is equal to 6x minus 3. It's the first thing I'm going to do, because if my definition is switch x and y, I want to make sure my equation has an x and a y. So my first step is to just switch x and y. So that's what I'm going to do. Now notice here it's just this y and just this x. It is not the number in front. So this should become x is equal to 6y minus 3. Okay, so all I've done here is switch those x and y values, flip-flopped them. Okay. And the next thing I do is I solve for y, or get y by itself. Now, if we're trying to get y by itself, it is our reverse order of operations. Remember, SAD/MEP. So I look for addition or subtraction first, which I do see. So I'm going to add 3 on both sides. That gives me x plus 3 is equal to 6y. I do see division or multiplication with this 6 right here. So I'm going to divide 6 on both sides. That's going to leave me with x plus 3 over 6 is equal to my inverse. Okay. Now, this is a totally correct answer, but we can simplify this a little bit more by breaking this into two fractions. Okay, so this is the same thing as x over 6 plus 3 over 6. Here I just took one denominator and split it into two fractions. From there I could reduce that if I wanted to, which gives me 1 over 6x plus 1/2 is equal to my inverse. Okay. Now this is correct and this is correct. Okay. Both of them are equally correct. It's important to notice or recognize that these are equal. Okay, so you can simplify it, but you don't have to. Now looking at this next one, very similar thing. Okay, but the solving is a little bit different here. Our steps are going to be exactly the same. The first thing that we want to do first is rewrite this with y, and I'm going to rewrite it over here just so I don't get confused with my work above. I'm going to rewrite this as y is equal to 12x minus 7 over 4. And then the first thing I do is switch those x and y values. So x is equal to 12y minus 7 over 4. So now that I've switched x and y, I can solve for y. Here's the tricky part here. This is all over or divided by 4. So the first thing that we have to do is cancel out this divided by 4. To cancel out a divided by 4, I'm going to multiply by 4. If I multiply by 4 on this side of the equation, I also have to multiply by 4 on the other side of the equation. So then these 4's cancel out. This becomes 4x is equal to 12y minus 7. And from here, your solving process should look very similar to the one above. I look for addition and subtraction to cancel out first. So I add 7 on both sides, which gives me 4x plus 7. These can't combine because they're not like terms, is equal to 12y. And I'm going to bring this over here. Sorry, I'm running out of room. So I've got 4x plus 7 equals 12y. And then y is not totally by itself yet. Y is still next to this 12. When it's right next to a number, it means multiplication. So I'm going to divide by 12 on both sides. If I divide this entire side by 12, I also have to divide this entire side by 12. So it's not just the 4 that's being divided by 12, it's also the 7. Okay? So I could leave my answer exactly like this if I wanted to, now that y is by itself. Or I could simplify this by breaking it into two fractions. 4 over 12, ignore that, 4 over 12x plus 7 over 12. 4 over 12 can reduce, and you can do that just by plugging in your calculator. If you do 4 divided by 12, it reduces to 1 over 3. So that can become 1 over 3x plus 7 over 12 is equal to our inverse. Now, again, this is a totally correct answer, and this is a totally correct answer. But on multiple choice tests like the ACT, it is important to notice that these are, at least understand that these are equal. This one is just slightly more simplified. All right, and on to our very last one, which brings in a lovely square root here. Again, we are finding the inverse. So our first step is to always, always, always switch our x and our y values. So I'm going to do that first. I'll get x is equal to the square root of y. Oops, that's the wrong color. Y plus 6 plus 2 on the outside of those parentheses. Now this one's a little bit trickier with our reverse order of operations. So again, I'm going to write reverse order of operations here first. Okay. Now, first thing I see is addition or subtraction. So the first thing I'm going to move is that positive 2. I'm going to cancel it out with a negative 2. That's going to give me x minus 2 is equal to the square root of y plus 6. Now this piece gets a little bit tricky because we see addition and subtraction again, but it's underneath this square root. We've got to get rid of this square root before we can do anything else. So what we're going to do to cancel out a square root, we square something. So I put this in parentheses and I square it. If I square this side of the equation, I also have to square the other side of the equation, which leaves me with x minus 2 squared is equal to the square root and the squared cancel each other out. So I've got y plus 6 on this side. And y is not totally by itself yet. So the last thing I'm going to do is subtract 6 on both sides. Outside of these parentheses, okay? Outside of these parentheses. We can't touch what's inside the parentheses. So your final answer should look like x minus 2 squared minus 6 is equal to our inverse. Trickiest thing about this is what to do with that square root and in what order to solve. All right, that is it for corrections on the quiz. From here, you can move on to completing the guided notes in the next video. Thanks.